Right, let's take a look at 2024 question 4 here. We have a snowboarder who is traveling up a ramp, yoo-hoo, and maybe going to do some cool flip up here, right? So with this scenario, we're told the radius, the center, and we're told all this kind of details here. So take time to read it through. And the student models the motion of the snowboarder, ignoring the effects of friction and air resistance. Okay, so show the forces acting on the snowboarder when he's at the point D, over here, where CD makes an angle alpha with the downward vertical. Now, just to be really clear, at no point do they tell us this is 45 degrees, like this is, halfway. So don't make assumptions. We don't know what alpha is. So in this case, drawing the snowboarder at that point, I can draw a rectangle or I can draw a circle. There is the weight component acting down, mass minus gravity. And there's also, he's pushing against the surface. So there's also the reaction force acting in that direction towards the center. Okay, make sure to show them nice and clear, clearly labeled, and you've got your 5 marks. Part 2, express the reaction force on the snowboarder at point D in terms of M, V1 and alpha. Now in this case here, there are 2 considerations I would take into it. One is I take into consideration forces, so when he's here, the forces, and the other consideration I would take into it is energy. I'll do the forces first. With the forces, be very careful with this one, and this is where people get really confused, I find. At this point in the journey, there's alpha, right? What we have is, we have something that is still in motion, right? So sometimes people feel the temptation, especially if they study physics, to say, oh, the upward forces here equal the downward. But no. This guy's still moving, right? So in this case, it is still accelerating, and the acceleration is towards the center of the circle, so the acceleration is this way. So we're going to resolve the forces in that direction. So in that case there, what I'm going to do is I'm going to draw this arrow down, and I'm going to say if this is alpha, this too is alpha. I'm going to draw this perpendicular to the direction. There we go. And in order to say that this is still moving in circular centripetal motion, the R value must be greater than this guy. So if this is mg, then this would be mg cosine alpha. And probably the most important part of this is taking the time to draw that and really get your understanding. So then I'm going to say for forces, to resolve the forces, I'm going to say that R minus mg cosine alpha must equal to mv squared over r, where v, just taking a moment to pause here, v1 is the start, and this new unknown one I'm going to call v. Okay, so with that in mind, let's resolve. Oh yeah, we're kind of nearly done there, but we're not going to get anywhere for a moment because it said to do it in m, v1 and alpha, but here I have it in terms of v. So I need to somehow relate this v, which a reminder is here, to this v here. And what I'm going to do for that is I'm going to take energy considerations. So let's talk about energy. So we have our first equation up there. Do you know what, actually, I'm going to go crazy and just put it as R equals mv squared over r plus mg cosine alpha. Now, taking into consideration energy. So if we take into consider energy considerations, right? This guy at the beginning has kinetic energy. Then when he gets to here, he still has kinetic energy, but some of it has been gone to raising his height in terms of potential energy. So what I'm going to do is I'm going to do it like this. Now you can do this a variety of ways, but I like to say energy before still has to equal energy after. Or you could say energy at point A has to equal energy at point D, right? So with this in mind, and moving on to the next page. Unfortunately, this went over the page, which is very annoying for any problem. But the energy before was kinetic only. So it was a half mv1 squared. The energy after, when it gets to here, we're calling it v. So it's going to be kinetic energy plus the potential energy, or the height it has raised by, mgh. Now, over to here again. Lots of flicking back and forth, but I need to work out what height, so this guy here, what height it's being raised by, okay? So I'm going to draw myself a little triangle. Now, this is 6.7, this whole thing is 6.7, and this is h, the height I've raised it by. Now, in order to figure out what that is, I'm going to say, okay, well, in this case, what is this blue length here? And if this is my hypotenuse and this is my adjacent, then I'm going to say that this blue length is 6.7 cosine alpha. So in total then, my height that I've raised it by is going to equal 6.7 minus this blue area. So I get it to be this here. Notice that the m's cancel and everything, so I'm going to cancel them all. There we go. Now, I'm looking for replacing this v squared with v1. So over here, I'm going to get this v squared alone. So I'm going to multiply everything by 2, and I'm going to rearrange for v squared. Now, I've taken into consideration now my energy and my energies. And next what I'm going to do is I'm going to plug them back into this equation here. Be super careful with this. A lot of places to make a mistake here. But I'm replacing the v squared with all the stuff that is directly above it here. So I'm just going to say, by the power of copy paste, because I have that technology. And just be super careful with this cleanup. I put this part over 6.7 just so I can add them together. Now, in this next instance, you can already see that I'm running out of space, and I do think this was a question that could have done with more space, but I have the power of shrinking this down, but you have the use of paper at the back of the exam, so utilize that momentarily. So now, have a look at things that look alike, so these guys add together. Now, what's very frustrating is the examiner left the answer in terms of G, which they didn't ask you to do, and a lot of people wouldn't think to do it. I'll give you the answer in the mark scheme, but also recognize that you might have said you might have had this as 19.6 and this is 29.4 because you'd left the G in. It would not be incorrect. It's totally fine to do. So just be aware that sometimes in the mark scheme he does multiply the G and other times he doesn't. The snowboarder reaches point B with a vertical velocity v2. Express v2 in terms of v1. Now, there are a few ways you can think about tackling this, and you can think about it saying, okay, assuming I'm at v, how much more to get to v2, right? But what I would sooner do is I'd sooner say, no. Let me consider the energy conversion from V1 up to V2. And here, it has kinetic energy. Up here, he has kinetic energy and still potential. He has had to rise 6.7 meters. So down here, I'm going to say, okay, let's think about energy. And I'm going to say at the bottom, it's a half mv1 squared. At the top, it's a half mv2 squared. Plus mgh, the height we've had to raise him by. So, simplifying that down, I get a half v squared 1 equals a half v squared 2 plus mg by 6.7. Express v2 in terms of v1. Sure, multiply everything by 2, just to get rid of those 2's. And finally, do the square root of both sides. You may have also had in this here as 131.32. That's okay. M, because you might have multiplied out the G, absolutely no problem with that. Part 4. A student at point B, the snowboarder leaves the arc and moves vertically upwards through the air. A student wishes to calculate V, the velocity of the snowboarder, t seconds after he leaves the arc. The force due to air resistance is now modelled as mkV. Draw a diagram showing the force acting on the snowboarder while he's moving upwards through the air. Okay, so you can draw a circle or you can draw a square. And the forces, or the rectangle, forces are acting down while its weight's acting down. Additionally, so is what I'll say is drag. Okay, that's it. Over here, show that while they're moving upwards through the air, the rate of change of V with T can be expressed by this differential equation. Okay, well, let's talk about forces again. So in this case, let's consider the forces acting on the body. Its net force is going to equal to MA. The net force here is, and we're going to say it's minus W minus D, because they're acting downwards to the direction of the upwards where his motion is. So here, I'm going to say minus W is minus mg. D, they tell me up here, was mkv. So I can say minus mkv equals ma. Divide across by a, factorize out the minus, and then I can replace a with dv dt. So therefore, dv dt. Lovely. Now, solve this differential equation to find expression for v in terms of t, k, and v1. Now, you got to be hyper aware here of what your v's are. And I found this question, personally, I found this confusing because there was 3 v's to consider. v1 down here, v2 here, and v here. So always just come back to it wherever you can and try to clear up where you are in a certain scenario. But for now, let's worry about solving this equation. So what I'm going to do first is I'm going to rewrite it to be dv equals this stuff times dt. And then I'm going to get rid of the g plus kv and put it underneath here. So I get dv over this stuff equals minus dt. Got to integrate both sides. And if I integrate both sides, what I'm going to get here is, it's 1 over something, so I'm going to do ln of that. But I need to remember that if I do ln of something like this, I have to also divide it by this differentiated. So I'm going to divide it by differentiate g, disappears, differentiate kv, just becomes k. Equals minus t plus c. Next, our first instance is to say, okay, do we know anything? Well, when t is 0, we know that v is v2. Okay, that's the moment when it leaves the guy up here. So the velocity, we know we're taking this time to be 0. So now with that in mind, do we have v2? And hey presto, we certainly do. We have it here. So now I'm going to say k v1 plus g. Okay, so I have c now, which looks mental. And now what I'm going to do is I'm going to go back to my, back to this one here. What I'm going to do now is go back to this guy here. And I'm going to replace in the c with this here. Yikes. Now, we're almost done. What I need to do is I need to get v alone. So I'm going to multiply both sides by k. Now, what I'm going to do is I'm going to bring the logs onto the same side, right? So I'm going to power of copy paste, bing, and I'm going to say minus this stuff here. I've brought this log over to the other side. Now, when logs are subtracting, I can do 1 divided by the other. So I'm going to say it now becomes ln of the stuff on top, the g plus kv, all over this stuff here. Now this is log e. So I'm going to say the e pushes this kt into the air. So now once we get to there, we're going to multiply both sides by what's in the bottom here. So I get g plus kv equals all this stuff times e to the minus kt. And believe it or not, we're almost done. We're just trying to get v alone. So we're going to say kv equals all this stuff minus g. And finally divide the whole thing by k. And there we have it. We've rearranged and made v the subject. We've written it in terms of v, k, and t. Or v1, k, and t, excuse me, as requested. Just to walk back through that, whoa. Take your equation, separate the dv dt, and then integrate both sides. Make sure to have your v's on the left-hand side. Watch for your log rule there where you divide by k, and then really just an ugly rearrangement, okay, to finally get down to here. Watch for when you've got logs on both sides, bring it over to one side, subtract them, and use your log rules of dividing there. Right, not a lovely question in my mind. very loads of little mistakes that you can make along the way. And as well, just at the end, if you're gotten a different answer, it's probably down to the fact that you might have multiplied out your G. So just take your calculator and put it in a 9.8 for those to see what kind of answer you get. And you could be right. Hope you found that useful. If you did, then like or subscribe, or check out the other social medias where I'll be adding extra resources. If you want something particular made, then just leave me a message on one of those platforms and I'll do my best to get around to it at some point. Best of luck in all your exams.